that's a lot of interrupts to pretty much eat up your entire week. There's a super high cost to that stuff, both from the customer standpoint and the engineering standpoint. As we're trying to onboard customers onto the platform, if their jobs end up on flaky hosts, their success rate is possibly impacted. Kind of builds a lot of mistrust in the platform itself. So there's a lot of social costs to having flaky hardware. And obviously the engineering costs, burnout, you hate your job, you're not really making progress because you're busy firefighting so much. And I mean, I think I'm guilty of this from previous jobs, and actually this has gotten me way away from that, is you pick up a lot of bad habits from firefighting. Before you really take a holistic approach on how you want to, support and kind of maintain this giant cluster, rather than dive right in and start fixing things, you got to look at it from a little bit higher up on the stack. So how do we fix all this? Automation, everyone's favorite friend. Before we dove in on this, there was lots of automation issues we ran into. Possibly being a little bit too aggressive. You run the risk of masking real world problems. I mean, if you're constantly just automating the reboot or the reinstall of the host, you might not root cause it. You might not be able to properly root cause the host. Capacity awareness. Can we even do what we want without taking down half of our cluster? That's one thing that we ran into that we've solved that problem. When do you want to automate? How big is your cluster? Is it worth automating considering how much time you put in? Is 100 nodes worth automating? Writing production level code also is difficult. So it might just be easier just to firefight. Making the time to really write good code and getting it right is also kind of a big challenge. So it's kind of one of the things you kind of weigh out when you decide if you want to automate this problem or not. So why things did have to change? Well, first and foremost, we were eating up a lot of SRE's time. Not much progress was being made. Cycles were in short supply. There were lots of Snowflake customers out there, so lots of competing interests in terms of stuff to support people that needed help. The clusters melting down. All while more customers were onboarding, so the cluster is continuing to grow. So failures became much more expensive, especially as stateful services decide to move into the cluster. So initially, we had this thing called COP, Cluster Operator. We had V1 of this service, which was written by one of the old superhero guys, and it pretty much did what we wanted to right off the bat. It stabilized the issue. It really kind of got us to a place where we're able to free up some time to work on things. And basically all it was a set of scripts that someone ran from their laptop every morning. It went out, it scanned the fleet, it identified a bunch of problems, and depending on the problem set that it returned, we either automated it or we jumped in and we kind of root caused it right then and there. It was pretty rudimentary because there were lots of unnecessary reinstalls, lots of unnecessary reboots. So, it's one of those expensive costs to automating the thing, but it worked and it actually saved us a ton of time. So, attrition happens all the time in business. So headcount went down on the team while we were still experiencing an increase in customer demand. So COP V1, those automated scripts, or those manual scripts became more important just because the hygiene of the cluster was suffering. And as folks left the team, there was a lack of subject matter experts on it. So does anyone know how this works? Can someone help me work with this? So it was just it was pretty tricky after a while. So eventually, kind of to give us a little bit of headroom, we just ported everything over to Mesos as a cron job, just to kind of give us some headroom while we could rethink our long-term strategy. So we look back at COP V1 before we kind of did anything, and remediation versus RCA, root cause analysis, it's kind of a tricky thing. If you're constantly firefighting, it's tough to iterate on improving your cluster health. Manual and automated remediation, it's tough to tell, with COP V1, was someone working on this already, or is the automator working on this? There was no real communication between the remediators and the maintenance tasks. Some of our stateful services were actually suffering as well, just because we had no topology awareness. So some teams that run on Mesos were running their services that we couldn't really, we would take down hosts for remediation and we would take their service down because their SLA was not up to par with our SLA. And the on-call handoff was really pretty much non-existent just because it was a script running in cron. So we took over the course of a couple of sprints and we said, let's rewrite this thing. We pretty much broke it up into 4 main services. COP v2, we have the provisioner, the signaler, an ad hoc API, and a real-time config. Provisioner, it's really helped us out a lot. We have a hardware engineering team that's constantly wheeling in new racks, burning in hosts. So now, once they release hosts to us, within 10 to 15 minutes, they're live on our cluster, and no one has to do anything. We have a signaler that hooks into our really robust and reliable Twitter infrastructure, monitoring infrastructure. So we get signals within 1 minute of a host having an issue, and the signaler fires a signal into the database to be remediated. The ad hoc API we've used actually to perform a lot of cluster-wide operations, Heartbleed, kernel upgrades, OS upgrades, you name it. We pretty much set it and forget it via the ad hoc API. And the real-time config is really great because on-call can come in at any time. And if the cluster is kind of not really responding very well because there's too many remediations going on, they're able to enable and disable signals and remediations on the fly without any sort of config change that needs to go out. So it's pretty awesome. So COP v2, we wrote it. It's a Python app, SQL Alchemy, MySQL, pretty simple stuff. We've added a lot of complex remediations, more granular approach to fixing issues, so lots of chained actions. As I said, hooked our detectors into our observability stack, which we trust. The REST API for ad hoc, UI for on-call, which has been really helpful because the SRE has a lot more free time now that they can work on more interesting projects, team OKRs, infrastructure OKRs, etc. We also have the ability to start tracking signals that we don't necessarily want to remediate, something that we might not, it's a new signal, it's a new failure. So before we write a remediator, we might want to start collecting the data saying this host is failing in this way now. It's something kind of interesting. So let's start capturing this data but not do anything about it. And the real-time config, which has helped out a lot in a pinch. So once we built COP v2, we dog-fooded it for a couple of weeks. On-call was only allowed to use it for remediations, no logging into boxes, no nothing. Everything had to be using our tool. After a few bugs and a few weeks of kind of improving on it and iterating, we gained some confidence in the system. We started enabling automated low-risk remediations, daemon restarts, and then after a while, we did some of the more high-risk stuff like reinstalling hosts, sending it off for repair. And today, I was looking at the stats, we're 98.5% of all our remediations are fully automated, which if you look back to where we were 9 months ago, it's a huge departure. So props to the team for that. Word got out around the engineering organization, and people want on the platform now. I mean, there are people who are kind of on the fence due to the known kind of instabilities in the platform, the flakiness in the hardware, what have you. But now COP has kind of given folks the confidence that they're able to come onto the Mesos platform, and it's really kind of helped drive efficiency across the organization. And it's actually a pretty great feeling to know that you've kind of collaborated on this and got folks excited about coming onto your platform. The feature set, the current feature set. So obviously you don't want to remediate too much of your cluster all at once. So we added budgeting. So you'll say you only want to remediate 5% of your cluster at once. We have partial and fully automated remediations, which pretty much handle all the known and expected issues. The remediations right now are kind of a pull model. So, we have our SLIs that we track through our monitoring infrastructure. And once that SLI is violated, a remediation occurs. Pretty simple. For the fleet-wide operation stuff, the stuff that we do via the REST API, it's more of a push model. We have a global key value store here at Twitter. So you set a key value for a set number of hosts. The workers come along, they pick up stuff, and they do stuff. So you want to upgrade all your entire fleet. You upgrade the operating system. You set it. You go to sleep. You come in the next morning. 1,000 hosts have had their hosts upgraded. It's pretty awesome. Pretty much anything you can measure and monitor, you can write a COP job for, which I think has kind of unlocked a lot of stuff. We've actually been iterating a lot faster on the team now as a result. It's actually pretty awesome. So lessons learned. Yeah, we could do this. I mean, when you first joined the team, I know I felt a little bit underwater just because the amount of stuff that was failing and breaking every day, and to look, after 9+ months of battle testing it, we trust the tool. It's done. It's definitely earned its weight. We've got customer enthusiasm way up, firefighting way down, and more collaboration within the team, which is really what we want. You can do more with less. As I said, we've got 3 SREs on the Mesos Aurora team, and 3 people managing 50,000 hosts is quite a lot. So you can do it. And at scale, we do a lot of data collection on COP. So we're a pretty data-driven team in terms of decision making. Intuition at scale doesn't work. So it's better to really kind of rely on the data to drive your next task than just to kind of say, well, I think this happened, or I think this is what we should do. So we've become much more data-driven as a team, which is great. Mean time to recovery at scale, it's varied and challenging due to the nature of the failures. We see hosts, week over week that fail in all sorts of new and interesting ways. So it's really tough to kind of nail MTTR down as kind of like an SLO. A few bad apples can swell the bunch. Yeah, we've got a few hosts like that. The graph you see here, the 2 straight lines are our budget, our repair budget, and the red line is our number of reinstalls that happened. And apparently, a couple of months ago, something changed, and we started blowing through our budget a lot, to the point where we were on track to reinstall the entire cluster, which is no bueno. So yeah, automation can definitely do more harm than good in this case. So you kind of need to kind of temper that as well. So looking back, overall, it's a great customer experience. Reliability is improved. The data that we're pulling from COP allows us to drive our SLOs for our customers. We have a much better understanding in terms of the overall health of our cluster. Signal detection, lots of different ways to slice and dice the data, the stats data that we pull out. So better cross-fleet signal detection. It actually helps us identify possible vendor issues. If we see a certain class of hosts having problems over and over again, we can actually let the hardware eng team saying, just so you know, this new batch of hosts is bad. So, it helps surface new and interesting failure domains. Once you kind of have a set of failure domains that you're comfortable with, the new stuff kind of bubbles up to the top. So it's a good way to surface new problems. It's definitely incentivized teams from joining for onboarding, which helps drive snowflake avoidance within Twitter, which is always kind of a challenge. So it helps our team out a lot that we have this tool that allows people to really kind of trust our platform. And again, much less interrupt driven for all of our ICs, which is for quality of life, that's actually a big deal. So what's next with COP? We're continuing to iterate on stats. We always want more stats. As I said, we're pretty data driven, so it's important that we really, if there's something we're missing or if we're kind of making the wrong decision, we pivot quickly and we make sure we get it right. KPI discoverability is always a bit of an art form, just because you think you might be, what might be the root cause that's causing this problem across the fleet might actually not be. So, more stats kind of help you get there. Per customer configs right now, if you're on the platform, all of our hybrid customers and all of our other customers within Twitter, everyone kind of gets the same set of rules, which we've added a bunch of tools within COP that allows other teams to kind of fail gracefully. But right now, we need to do a lot more around per customer configs. And we're getting there for sure. Conclusions. Yeah, managing OVN bare metal hardware with OV1 SREs is most certainly possible. Every week we're getting new hardware. Every week there's still 3 of us there. So it's been a really interesting it's been a really interesting year on the team. If you've ever experienced similar challenges with managing infrastructure, come find me. We'd love to talk to you. It's actually, Mesos is kind of the bottom of the funnel. It's where a lot of our services at Twitter are coming to. So as always, we're hiring. So if any of this stuff sounds interesting to you, working at scale on hardware, as well as supporting a lot of people in the company, come find us. We'd love to talk to you. Thank you.
You may want to go back to your first slide where your contacts are.
Which one?
Your first slide where your contacts are.
Oh, my first.
Yeah. I got to ask, I'm seeing sometimes static links, you do notifications, you click on them, they go to the link and they're not there anymore. Static links. Yeah, like links that are from notifications. Mm-hmm. Is that because maybe a cluster threw it out, fixed it, or something happened? And I see it from retweets a lot, so I'm wondering what that may be.
Well, that's an interesting question. So the question for the back of the room is about static links?
Yeah, you'll have a link that somebody shared, and then somebody reshared it and mentioned it in their tweet. Oh. And then when you click on it off a notification,
that stuff bubbles up to the actual service itself. That stuff happens much higher up in the stack than us. I'm an infrastructure guy. So the stuff that happens on Twitter itself, unfortunately, that stuff bubbles up to the actual product team itself.
Yeah, I'm a Cisco guy, so usually that means that there's some backup infrastructure tool that hasn't actually
all the various
that.
Sure, all the various queues, all the RPC that goes on behind the scenes, that stuff's all monitored. All the various teams have their own set of on-calls. So if there's failures within the service itself, I don't have a good answer around that, but
I just mentioned it because I know we were here 2 years ago when you guys first showed your Mesos stuff and also these custom VM you built, which is awe-inspiring. I love the fact you've open source some of it. Just open source as a stack. Just please give it to us as a framework. It's badass. Sure. But how do you then guarantee as more devices are going to be faster, running in SSD drives, running in systems that are really what are de facto in-memory, high-frequency level performance? Sure. How are you going to keep competing, be able to provide what we're now listening from Amazon and others, which is my perception?
Sure. Yeah.
Availability memory.
The head of our team works really closely with the hardware engineering team, and they dog food all sorts of new different types of hardware, SSDs.
Yeah, because the load's coming from these systems.
Sure.
Yeah, you've done a good job. Like the redesign of your web app, it's really good. But we know that there's another level of performance coming that you've got to get ahead of. So I'm just asking.
Yeah, well, we actually use COP to do a big hardware refresh. So we've got lots of brand spanking new machines with lots of cores and lots of disk and lots of RAM. So we're not the bottleneck. That's for sure.
Cool.
So,
just checking.
But we definitely support, all the different customers that we've got. We try to give them the most stable platform that they can run their servers on. Yeah.
What is the most unexpected challenge you guys ran into while organically building product?
Too many people working on something at once. That happens a lot. We talked about with COP V1, we had a lot of remediations that were going on and getting out of that firefighting mode. I would personally jump on a box that was alerting, or a few boxes that were alerting, and COP V1 would pull them out from under my feet while I'm working on them. So kind of like getting out of the mindset, breaking the mindset of firefighting. Most of the problems that we solve, I would say, are social problems, learning how to kind of troubleshoot a different way. The technical stuff, I wouldn't say it's easy, but getting signals, building detectors, that stuff is kind of the fun stuff. Breaking habits and really kind of taking a different approach in terms of how you're going to fix this stuff is really kind of the biggest problem. And definitely when we were running V1, it was definitely something that we kind of had to get out of the habit of. Yeah.
How do you stage, say, fleet-wide deployments? There might be differences in how the computers are set up, right? Mm-hmm. So how do you stage something like that to be deployed over so many computers?
Well, one thing that we do before we intake hosts into our platform is that we wipe them and we kind of get them into compliance what we need on the system, like the file system layout, certain ways that like the C group, the C groups are set up, etc. So it's really all just about the intake process and making sure that works. A lot of times, hardware eng just gives us a bunch of hardware, and this has happened before where stuff gets added into the cluster and it's actually configured completely wrong. So we quickly submit a number of jobs to say, like 20 hosts, reinstall these hosts really quickly. They're drained, they're sent back for reinstall, and they come back into the cluster 30 minutes later and they've got the proper, the proper base image. So, but it's up to us to really detect that stuff, and that's kind of something that we're iterating on.
So this may be part of the stuff you're going to do in the future.
Sure.
But one of the big things about hardware lifecycle management is the stateful service that might be running on it.
Sure.
Where you have to go through if you know you're going to take something out of service,
Yep.
say it's an MySQL master or something,
Yeah.
you'd like to run the application-specific remediation that your team probably doesn't want to write.
Well, that's our guess. Well, we've actually reached out a lot of our customers. Just this past week, we pushed coordinators that we onboard stateful services onto the platform. We let them know, look, if you're on the platform, there's possible you're going to be yanked out from underneath you. So we need you to write this coordinator that we actually hook COP into to say, I'm going to drain these 10 hosts. If your service is on any of these hosts, it's going to ping the coordinator and it'll either say, go ahead and drain me, or it's going to say, come back in 20 minutes. And I think we have a timeout of like 7 daas. We give teams 7 days to vacate a host before we fully take it out of service. So
That's badass.
Pardon?
Mesosphere has published a ton of these, of their own versions of those.
Of coordinators?
Yeah.
No, the guys that wrote it are sitting behind you, so maybe they can talk about it. But I mean, I know it's been a big win, and it's actually gotten a lot of adoption as a result. Because
right now, though, you're writing your own coordinators. You're not.
Well, the customers are. I mean, it's just pretty much an API call before we issue the drain to their service, and say, we have can we drain you? And they do all their, each stateful service is going to have a different way of draining itself. So it's up to we just call out, and however they decide to implement their draining is up to them. But it's definitely something that's helped drive adoption, which is actually a really big win for us.
So you were talking about how you don't, well, nobody should be using intuition to rule any of their big decisions. So once you started doing the signaling and you started to see, where the problem hosts were, and how they were commonly coming up, I'm assuming, how did you then send that information back to the hardware team so that they knew oh, okay,
Sure.
Stop buying this model, using these drives, that kind of thing?
Sure. Yeah, I mean, there's a lot of, it's basically just it's pretty much just taking the stats that we've got and pretty much, that part of it is kind of a bit of a manual process because it's kind of like post-processing of all your stats to kind of look up the host, look up the SKU and all the various things. But we have each host that's in their service has kind of a corresponding host database. So any host that has an issue, we're able to perform a lookup and do any sort of bucketing based on any number of things, the RAM, the CPU, the number of cores, et cetera. So we have the data, it's really up to us to kind of just query our host database, our global host database within the company and give the data back to hardware engineering. It's really not any sort of black magic. It's pretty much just like we have a list of host names, and then we could just query the host database and get all sorts of information about these hosts. And like I said, we just bucket them and send it back. And thankfully, we haven't had too many problems, but we did just have this big hardware refresh. So a lot of the old crappy hardware is long gone. So we have lots of hot new stuff that we're working on right now.
I was hoping that maybe that validated the intuition you had previously. This particular team cluster, you always know it's got problems. Every Monday you come in, oh shit, we got to deal with that again.
Yeah, I mean, certain people's workloads run different ways. So I mean, that's kind of why we need to push on per customer configs, just because certain thresholds work for us that don't necessarily work for other teams, just because certain clusters run hotter than others, et cetera. So that's kind of some of the stuff we're kind of pushing towards, is kind of getting folks away from this global we want people to be able to manage their own destiny. If they want to ignore certain types of alerts that go off, or if they want to kind of tweak their thresholds way up because they know they run their stuff extra hot, like during World Cup or what have you, we want to be able to give them that ability. So it's really just, it's up to us to give them that flexibility.
How are you managing the OS install?
Well, we have an OS team that pretty much, they set the mandate. We do, recently we did kind of a, like a point release update, and kernel updates and stuff. We've got a kernel team and OS team, which they work together. So we just, given that we've got all these coordinators in place now, it's really just a matter of setting in our REST API. We say we can take 50% of, first we canary it obviously, and we say we're going to take 1% of the hosts and upgrade them. We set the key value store for 1% of all our hosts in COP, and it goes out and does all the necessary, it reinstalls them, or it actually does the Yum update, for example. And then we pretty much watch them. We watch them bake for a couple of weeks, and then we dial it up to 2%, 5%, 10, 20, whatever. So, but yeah, in terms of OS stuff, we don't really. We trust the OS team for that stuff.
Yeah, you just call it self-controlling OS.
It calls to a service that actually performs the Kickstart. So, and the Kickstart infrastructure is really, really flexible here. So. We've got folks that are still running on CentOS 6. We've got some folks that are running on CentOS 7.4. So whatever flavor, whatever OS you need, we just have to. We can set that in COP as well to say these hosts set to this OS, etc. Yeah.
What are
Yeah, go for it.
Oh, I thought someone was going to. Yeah. What are some of the things in the future you think are good for the space around Mesos and Aurora, and things you'd like to see even if it's a debate here? And what are some of the things that you think are really interesting that for SRAs that we kind of need to think about?
Yeah. Before I worked on the Aurora team, I think the largest cluster I managed was like 200 hosts. This team, Twitter scale is a real thing. If you're able to save one, like recently we have system resources that we've identified as being orphaned, whereas people use all the RAM in a box, which leaves all the CPUs. So we have a lot of orphaned resources. So some of the folks on the team worked with reclaiming those orphaned resources, which moved a bunch of jobs around, so you get better bin packing, so you can fit more hosts on the server, and it, without actually doing anything, without spending $1 of hardware money. You're spending software engineer money. You save the company millions of dollars because you're actually reclaiming resources that would have sat there idle for weeks and months. So we're getting much more efficiency out of our cluster. And that's the kind of stuff that I think is really interesting, at least for the kind of work that I do. Did I mention we're hiring?
What are you looking for with people you hire?
People that really want to
Come talk to
work on fun stuff. Yeah. We're a great bunch of folks on this team, and across the entire organization. Ramin, Brian, these guys. These guys. These guys are great folks. All right. Thank you so much.
All right, thanks for coming tonight. That's the end of our speakers. We have the room until at least 8:30, so if you want to hang out and talk to coworkers of the companies, feel free. We're not going to kick you out right away. And then I will be announcing the next meetup, which is July 18th. And we're going to have Emily Cole doing a talk about security, and then I believe I have one more speaker ready to go. But if you do ever want to speak, please come talk to us. We're always looking for talks. Anything from like 5 minutes to about 30 minutes is generally the sweet spot. We find the longer talks, people get a little bit bored, or they need to go catch a train and they can't stay for the whole thing. And honestly, if you want to come rant for 5 minutes about how artifacts are terrible, you hate config management, that'd be great. I've totally done it, so feel free. So yeah, please hang out, and thank you for coming.
So you're gonna show up with a picture of top cut Kool-Aid next time.
I'll never remember it.
The man is probably worried about his face.
Perfect.